Hey guys, my name's Ryan Peters and I am a musician from Australia. Today we are going to be having a look at what is sound. That is a very broad question and topic, but we're just going to stay in the realm of what is sound, looking at it almost as an audio engineer's point of view. If you use a DAW, if you use recording software, if you record yourself or do any type of computer music, hopefully you're going to get something out of it. We're going to have a look at how sound is made and how sound is represented. We're going to do that through some different pieces of software. We're going to have a look at how it's represented in this software, and by doing that we're going to see how sounds are actually made. So stick around and let's get into it. Have a listen to this sound. If you heard that before, that sound is called a sine wave. And this is what the waveform looks of it. So this is a sine wave, but this is how the computer reads it. So what a sine wave is called a pure wave. It's a very smooth wave going up and down. What that line is representing is actually how the speaker moves back and forth. The speaker moves back and forth very smoothly, creating that really nice and pure sound. What the height of that means is the volume. So if this wave here that we see is going to be bigger upwards, that means it's going to be louder. Now, see these peaks and troughs? The peak is the higher point of the wave and the trough is the lower point of the wave. If those peaks and troughs are further apart, that means the pitch is going to be lower. If they're pushed together, that means the pitch is going to be higher. So if we zoom out now of this wave, we can see it's starting to look like a waveform. And we can see there, we can actually see the volume of this wave. We can see up the top, it starts a little bit louder and goes down and becomes the same volume. You can see in the middle, the waveform becomes the same volume and doesn't change at all. You may see in your recording software or your DAW, waveforms that look like this, and they are a very good indication of how the sound is behaving. If you see it going up and down, that means the volume is getting louder and softer. But if you see it start up the top and come down, then the volume is getting quieter. Have a look at this waveform of someone singing. We can see that the volume is quite varied. We can see in this part that the volume is staying relatively the same because the shape doesn't get bigger or get smaller. But we can see in the next shape it gets quite big and then travels down a little bit more. So just by looking at this wave we can see the volume. And then if we look even closer, we can see what the pitch is. Have a look and listen to this. What this is doing is showing us a few things. First one is showing us where the pitch is. If we have a look back at our software, we can see that the pitch is around 258 Hertz, and we can see that from the yellow sign there as well. We can also see the volume of this specific note. If we go up here, we can see it's just a little bit past the line. And then if we go over to the right here, we can see that the volume is around minus 30 dB. What does that tell us when we're working with audio? Well, we can see what frequencies are softer or louder than each other. And it tells us where we can EQ things or where we can change our sound design. Having a look at this software, it tells us that this sound only has that single sound playing. It only has a sine wave. So this graph shows you where the sine waves are. This is because the sine waves are pure waves and it's what other sounds are made up from. That might sound a little bit confusing, but I'm going to show you what I mean. 1, 2, 3, 4. Have a listen and look at this. 1, 2, 3, 4. So that's my voice. And what it's showing you all the sounds that are playing together. You can see when they move in pitch. You can see when they also move in volume. Let's now dissect that and see what they're actually doing. We're going to play this on loop for a little bit, but we're going to narrow down all these frequencies. 1, 2, 3, 4. 1, 2. So now the only frequencies are playing are between those two lines. And what can we hear? Well, it sounds like a sine wave, doesn't it? So what does that tell you as well? If we scroll up a little bit in the sounds, we can hear again sine waves. Nothing much there. We can hear the pitch of my voice when I was talking, but we can't hear the rest of it. So there is showing us that all these sine waves produce sounds that we hear in daily life. So every single sound is made up of stacked different sine waves, and that creates the sound that we can hear and recognize. I'm going to show you one more thing just to prove this theory and show you how sound works. 1, 2, 3, 4. 1, 2, 3, 4. What I'm going to show you now is called a spectrogram. It shows you similar information to what we saw with our sine wave and me talking and singing, but in a bit of a different way. Let's have a look at it now. So here's my software and here's my voice. I just recorded again. Let's have a listen. 1, 2, 3, 4. Okay, me just talking. But what does this information actually show us? Well, if we have a look, we can see kind of bluey black background almost in a way, and it looks like there's been lines painted on it. Well, we can see from this line over here, the lighter or the more yellow or orange it gets, the louder that specific sound is. So going up, we can see if it's black, there's no sound there. But if we go to white, that's going to be very, very loud, or that specific sound or tone or frequency range is going to be. And we can see here we have our frequency range going all the way to 100 Hertz, going up all the way to 20,000 Hertz. So going up, we can see our Hertz, the color is the volume, and obviously going across is our timeline. So let's now have a listen to it again, but I'm going to restrict these sounds so we only get half of what we hear. 1. So you can see I've only got the bottom half grayed out. So that grey section is only going to play and not play the top half. Let's have a listen. 2, 3, 4. 1, 2, 3, 4. Sounds like the quality is completely gone. It sounds like it's a really crappy laptop speaker or a phone speaker or something that's even 20 years old. That's because all that high frequency information is cut out. Let's now have a listen to the opposite of that and only hear the high information. Again, sounds really, really bad quality. It sounds like something's missing or the speaker's damaged or like you've even got water in it in a way. That's also saying that to get a good quality sound, you need all these frequencies, or you need to be able to hear roughly all of them, depending on if you're EQ. That's a story for another time. What I'm going to do now is only select the bottom color right down here. Okay? You can see it's probably the loudest, and you can see it moving as well with my voice. Let's have a listen. And again, what does it sound like? Sounds like a sine wave. So the more we go up, the more sine waves you're going to hear, and the more my voice is going to be recognized. I'm going to play the sound now and slowly go up, and you're going to hear my voice come into light. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So what did we just learn? We learned that all these different notes create my voice. And again, they create every sound you hear in the real world. Every sound requires a bunch of different other sine waves or other sounds stacked on top of each other to create the tonal characteristics and the qualities that we can recognize and understand. And on top of that, to get a good quality sound out, you need all these frequencies on your speaker or in your mix or in your recording. And so that brings us to the end of this video. We learnt about what a sine wave is and what the sine wave looks like. And we learnt how to see it in an EQ plugin showing where the frequency sits and the volume. And then we also had a look at how all frequencies are combined to create sound that sound like one sound, which I think is a very, very fascinating and interesting piece of knowledge, and hopefully becomes useful for you one day in your life. So there you have it. There's a brief look at sound and the physics, and also how it's represented in different softwares. So hopefully you've learnt something. If you have any questions, feel free to leave a comment or give me an email. Feel free to check out my other YouTube videos or my music. All my links are in the description below. If you want to check out any of the software as well, all the links will be there. And until next time, cheers. 1, 2, 3, 4.